Welcome to the end of the atomic theory in chemistry honors. But before we do that, I do have to make an apology. So, apparently one of my videos where I asked you to comment, the comments just got turned off. Somebody in person told me I should do a video of the Miami NBA Heat game that I'm going to. So, just find a video and comment it there. I'll be watching all my other videos. I do apologize for this, but I can't do anything about it, unfortunately. Maybe I can. I don't know. But this is modern atomic theory. So the Bohr model made a lot of shortcomings. It tends to suggest that the electrons are found on fixed tracks around the nucleus and does not account for the fact that electrons travel at high speed, which throws off the math of the motion. Literally, the Bohr model was made off of hydrogen, but if he had used helium, he would have seen how his math was off. Helium. That's all he had to have done was throw in one more electrons because of the force between the two electrons. You've heard of the IMFA's intermolecular forces of attraction. Well, this is kind of like the IEFA's inter-electrons force of attractions. It isn't really, but if you want to think of it that way, then go for it. So then we have the Heisenberg uncertainty principle. Now, if you're like me and you have the Guttman uncertainty principle, that is, I'm uncertain of what I got on a math test. But for Heisenberg, his uncertainty principle was that because electrons are moving so fast, it is not possible to know the exact location and the velocity of the particle. The principal energy levels is that since we are uncertain about the exact location of the electrons, each energy level is only in a place where the electrons are probably found. Although this was eventually narrowed down. We are now at modern atomic theory, the wave mechanical model. Shorter wavelength is greater energy. Schrodinger, the person who also did Schrodinger's cat, which I don't exactly memorize, developed a complex equation that gives us the wave mechanic model of the atoms. The solution to this equation gave specific wave functions called orbitals. The orbitals are the path of an electron is not a circle with a definite radius. The region in space around the nucleus is where the probability is located. The principal energy levels are devoted with numbers 1, 2, 3, 4, and so on. This is the main areas where the electrons might be found. They are not circular paths and they're called quantum numbers. So, K to 1, L to 2, M to 3, N to 4, so on and so forth. This is a quick video because this is all we really did in chemistry today. And Mr. Adelberg told us that the cliffhanger I left you off with, he's not going to actually talk about until the next unit. And he told us that chemistry is full of cliffhangers. So if you're watching this, I would say you're probably going to be waiting until, at the earliest, late December. And probably until January. Probably until the New Year's when I'm actually going to be able to teach you about this. And I do apologize for that.